RetroSign GRX is a new and modern instrument for measuring retroreflection of road traffic signs, high visibility clothing, license plates, and reflective tape on site. GRX measures the coefficient of retroreflected luminance at night, RA, and comply with existing standards like EN 12899, EN 20471, ASTM E1709, and ASTM E2540. GRX is built over the latest developments in sensor and digital camera technology, offering a range of valuable features, some of them not seen before in a retroreflectometer, like measurements of up to 7 observation angles simultaneous, measures 7 entrance angles by changing the front adapter, taking photo of the measured sign, automatic sign color recognition, contrast calculation of background and legend colors, built-in GPS for location identification, built-in barcode and QR code scanner for asset management, instrument tilt and rotation, sign facing direction, manually entered pass and fail values for background, legend, and/or contrast measurement values, temperature and relative humidity measurement, and extension pole for measurement of elevated signs. RetroSign GRX is offered in 3 base versions: GRX 1, GRX 3, and GRX 7, where the figure in the name tells the number of observation angles provided. GRX can store more than 2 million measurements without sign pictures and more than 2,000 measurements with pictures. Each GRX instrument will contain all the features which can be offered with the instrument, but just those features paid for will be available to the user. The user may later decide to upgrade his or her GRX via the internet against a fee. As other Delta instruments, GRX is robust and is easy to operate. GRX will last for years with a minimum of service when treated properly. GRX is very easy to operate with the possibility to enter numerous sign-related data. Measured data is easily transferred by USB to a PC for analysis in existing software like Excel and Google Earth, or by Wi-Fi to a tablet for storage, processing, and mapping. The tablet can be used as a small asset management system with data search capability, as well as send measured data to the company back office instantly after measurements if required. For more information about using the tablet, please consult the GRX user manual. After this brief introduction of GRX, we will present all the functions of the instrument. This will allow you to understand the features offered by GRX and will train you to be able to use the instrument correctly for retroreflection measurements. First, we will look at the outside of the GRX and locate the various parts relevant to the use of the instrument. At the front of the instrument, we have the light source based on LED light, the measurement sensor for reflection measurement and color recognition, and the digital camera for photo and code scanning. Over the instrument front, an angle adapter for entrance angle is mounted. The available entrance angle adapters are -4 degrees, +5 degrees, +10, +20, +30, +40, and +45 degrees, of which the first 2 are standard angles for ASTM and SEN sign geometries. Each angle adapter type has a unique combination of magnets on the back informing the GRX what adapter has been mounted. The entrance angle type can be viewed in the GRX display. The adapter itself is fixed to the instrument by magnets. GRX comes with a 5-inch Android color touchscreen, easily visible also in bright sunshine. The instrument can automatically adjust the screen light intensity depending on the ambient light. The handle holds the trigger and a rechargeable battery. The battery is a Bosch type and can be purchased from the market. The following features are located underneath the instrument: USB port for data transfer, power button, service port, buzzer, loudspeaker, and fixture for extension pole. This instrument is turned on by pushing the red power button under the instruments. After some time, the system has booted and the instrument will be ready for use. The GRX automatically switches to standby mode if not used for a period of time. The length may be adjusted under settings. From standby mode, the instrument is ready within 1 to 2 seconds. To activate standby mode, push the power button shortly. To switch off the instrument, push the power button for a few seconds until power off is written in the display. When turned on, the instrument always go to measurement mode and show the measurement information from the last measurement. The touchscreen is based on Android technology, and the user can operate the screen by using these movements: tap, swipe, and pinch. We will look at the many features offered by the GRX when measuring retroreflection of retroreflective materials like signs, license plates, and reflective tapes. This is how the main screen of the GRX looks in measurement mode. At the top of the screen, we can locate the following icons: Wi-Fi hotspot, system warning, GPS, Bluetooth connection, Wi-Fi signal, battery status, and time. At the top left corner of the second line of the screen, the menu can be opened by tapping this icon. Opening the menu can also be done by swiping the screen from left to right. At the top right corner is information about the angle adapter type attached and information about the measurement series activated with the number of measurements in this series. We now open the menu. At the top of the menu is the name of the user located. The menu consists of the following elements: measurement, series, users, templates, log, calibrate, and settings. We will now focus on the operating information explaining how the elements work and how measurements are set up and conducted. We will review the items in the order in which we would suggest the user does. In general, when you enter data or measure, data are automatically saved. Settings. Wi-Fi. In this section, Wi-Fi connection can be activated or deactivated. The Wi-Fi connection is used for wireless data transfer to and from the GRX app to the iPad app. Bluetooth. In this section, the Bluetooth connection can be activated and deactivated. The Bluetooth connection is to activate measurements when using the extension pole for elevated placed road traffic signs. Hotspot. In this section, a Wi-Fi hotspot can be activated or deactivated. The Wi-Fi hotspot is used for wireless data transfer to and from the GRX app to the iPad app. Sound. In this section, the instrument's sound volume can be adjusted on a scale from 0 to 15. And the beep function can be activated or deactivated. Display. This section allows the user to choose between user-controlled display brightness on a scale from 0 to 100 or adaptive brightness. When the adaptive brightness is activated, the instrument adjusts the display brightness automatically according to the level of available light. The sleep function allows the user to decide after how long time the instrument automatically turns into sleep mode after inactivation. The function can be adjusted between 15 seconds and 30 minutes by tapping on the display. Location. This section allows the user to completely disable location tracking. If location is disabled, there will be no location coordinates associated with the inspection. Language and keyboard. This section allows the user to change language and keyboard layout. GRX is running on Android, and all languages available to Android will be available for selection. It will, however, in the instrument menu, only be the languages translated and transferred to the instrument memory, who will show up translated in the instrument menu. Date and time. In this section, automatic date and time and automatic time zone can be activated and deactivated. If one or both functions are activated, the instrument will automatically use internet-provided information. It requires Wi-Fi connection. About instruments. This section holds information related to the instrument setup and function. This is information which Delta may ask access to in case there's a problem with the instruments. If you need more information on any of these points, please check the user manual. Calibration. It's important to make a daily calibration of the instrument to ensure it measures correctly. This is typically done in the morning before measurement is started. There are two ways to start the calibration procedure. One is to type in the figures of the different observation angle as seen on the screen. The other one is to scan the barcodes. We will do the scanning of the barcodes. The instrument will automatically focus and capture the different values. Next step is to mount the calibration reference on the front of the instrument, do the calibration, and within 1 or 2 seconds, calibration is done. The relevant tools for doing a calibration is located on the back side of the angle adapter. Here you can locate the values to calibrate up against for the different observation angle, the barcode for the scanning, and the calibration target where the actual calibration is done on. When the calibration figures have been entered into the instrument, the angle adjuster with the calibration target on the back has to be turned around to be able to make the calibration. Users. Under users, it is able to edit existing users, enter new users, delete users, and also filter if you have a lot of names and want to search to locate a specific name. We will now enter a new user. It is done by pushing the plus. We will type in a name. We will take Mark. OK. And now Mark is entered. The name that has been marked is the one that will automatically be used for the next measurements. All entries are automatically stored. We will now create a template. A template can be used if there is a larger measurement series which have the same basic data. So in the template, all the basic data will be hosted and will be used for each series of measurement that will be entered and activated. This is the one where we can edit an existing. We don't want to do that. We want to enter a new one. We will call it Highway 45. We will choose a multiple shot. Single shot is not activated here. And we will choose 2 background measurements and 2 legend measurements. And we also decide to take a picture of the sign. There is 12 predefined fields which we can choose between, add to the template. We will choose a few here. We will choose one that is called Legend and add it. And we will choose one called Sheeting Legends, and we will choose a last one called Owner. If that is not enough, it is able to add additional fields. Sign ID, we can, for example, give it 2 to 4. Legend, we can, for example, say blue. And we have a drop-down list on sheeting legends. We can say it's a type 7. And we can say the owner is the authority. We have now created a template where we can do 2 measurements of both legend and background color and make a photo of the sign. In the previous selection, we decided for multiple shots. If single shot is required, we can activate this function here. Single shot can be used if just a single measurement is needed for one color. In single shot mode, no photo of sign will be available, but the pass-fail function can still be used. It will also be possible to activate manually entered pass-fail values. As an example, we have set 40 candela for background color, 200 candela for legend color, and no value for contrast. Activating pass-fail function will allow the instrument to instantly inform after each measurement if the sign has passed or failed the minimum. If we want to edit or remove a template, we can sweep to the left and tap the Activity button. The instrument will automatically detect the color measured. If the color is not correctly identified, this can happen if colors are faded. It will be possible to manually correct the color before a measurement is approved. The last part is to create a series, which is the actual measurement series. And we will choose here a new one. The first it asks us is to select the template. We take the one we just created, Highway 45. We will have a name for this series. We will call it Test 21. And you will see the information we entered before under the template is available. If something needs to be changed, it can be changed. If some additional fields need to be added, they can be added. We are now ready to make a measurement. By pulling the trigger, we will see the information we have requested for this measurement series. We can still do some changes if we want to do that. If we are satisfied, we push Next. The next step is making a picture of the sign. By tapping on the screen, we are focusing the sign. We do the measurement and we accept the photo. Now we have to place the instrument firmly against the first background color measurement and measure. We get a warning on no GPS fix because we are indoor. We are asked to do second measurement of the background color. The first measurement of the legend. And the second measurement of the legend. As you saw, the instrument guides you to what measurements to do. You also saw that the instrument automatically detected the color, the first two measurements, the red background color, and the last two measurements, the white legend color. We confirm the measurements. We can now view the data. We see here a small picture of the sign. We have the two colors, the white and the red, with three main observation angles, the 0.2, the 0.5, and the 1 degree, according to the US ASTM geometry, which we are using here. And we have a curve with all 7 observation angles for the white and the red color. On page 2, under the header, we have the basic information about this measurement. Under measurement data, we have the 7 observation angles, the legend and the background color, and the individual measurements. And the instrument have automatically, for each angle, calculated the contrast. Further down, we have the sign data, which we have entered before we started measurements. And at the bottom, we have what we call secondary measurement data. That's the phasing of the sign, the tilt of the instrument, the rotation of the instrument, the temperature, and the relative humidity. And on the third page, we have the full-size picture of the sign measured. If we are going to enter information to fields in the sign data section by scanning a barcode or a QR code, this is done by swiping the specific field to the right and tap Scan. The code is scanned and automatically transferred to the log. Below Take Picture, we see a new field, Select MUTCD Sign. Tapping on this field, the user will be able to access the United States MUTCD library if purchased with the instrument. With the library, the user can call forward the particular sign from the library he or she is going to measure with minimum retroreflection values. When measuring the sign, the GRX will automatically inform if the sign has passed or failed the minimum level required. Please consult the user manual for further details. The last section is the log. In the log, we can view the different measurement series which we have done. For each series, we have the option to export and delete. We will revert to export in a short while. By tapping, we will open up this measurement series which we just did. It consists of 2 measurements. We see in this part here the 2 colors, the 3 main observation angles, and the contrast. By tapping, we will open up one series and we will see the same data, the same information as we viewed just before under measurement. For export of measurement data to a PC, a USB memory stick is used. The USB is positioned in the USB port underneath the GRX. To transfer measurement data, go to the GRX log, choose the file to be exported, swipe to the left and tap Export. Next, choose what files you want to transfer. Excel as horizontal view, Excel as vertical view, Google Earth view, the sign footer as a file. If thumbnail is activated, a photo of the sign will be added to the Excel and Google Earth views. The data output will look like this in Excel. If pass-fail has been activated, the individual measurements can be viewed in green when passed and in red when failed. The Google Earth view will look like this. It is possible to transfer GRX measurement data from the instrument to an iPad for data backup, data processing, as well as preparing presentations and mapping. The iPad can also be used to send measurement data back to the office shortly after the measurement program has been finished. The RetroSign GRX app can be downloaded from App Store free of charge. The instrument needs to have the optional Wi-Fi feature installed for communication with the iPads. Please see the user manual for details. GRX has a few features which cannot be turned on and turned off, and therefore not directly visible. One is the instrument rotation and tilt. Instrument rotation is if the instrument is rotated around its axis. This can be relevant if you are measuring direction-sensitive microprismatic sheetings. If you measure those sheetings in the vertical level and the horizontal level, you will see there's a difference in performance, and this way it can be investigated if the sheeting material has been correctly mounted on the sign face. The tilt is to see if the instrument is tilted when a measurement is done. If an instrument is tilted, it may mean that the measurements are not 100% correct. Sign facing direction is using a compass in the instrument which can tell in what direction the sign is facing in relation to north, east, south and west. This can be relevant because a sign facing the sun will be more exposed to light and degradation and thereby last shorter time compared to a sign facing away from the sun. The extension pole is used for measuring elevated road traffic signs which cannot be measured by a person standing on the ground. The pole adds 1.5 to 2.7 meter or 4.9 to 8.9 feet, allowing measurements of most elevated signs. A measurement is activated by a push button and Bluetooth connection. Before you can use the Bluetooth connection to measure, you need to pair the button with the GRX. See the user manual for details. To mount the GRX on the extension pole, a fixture has to be installed on the GRX. The fixture is securely tightened using a screw and a screwdriver. Now the GRX can be mounted on the extension pole. The wing nut can be used to tilt the angle of the instrument relative to the sign. The instrument is powered by a standard Bosch battery, which under normal use requires no maintenance. The battery is equipped with a thermal sensor that only allows charging within a range between 0 and 45 degrees Celsius or 32 to 113 degrees Fahrenheit. The operating range of the battery is 0 to 60 degrees Celsius or 32 to 140 degrees Fahrenheit. The battery will be fully charged in approximately 45 minutes. Errors and warnings. The GRX sends out warning signals in case of an error and operates with these two types of warning symbols. In the user manual section 4, a list of errors and warnings can be accessed, including the possible cause for the error and how to resolve it. Maintenance. The RetroSign GRX is constructed for outdoor use in fair weather conditions. The retroreflectometer can withstand moist weather, but caution must be taken against rain or splashes and dirt from traffic. Even though the GRX is a robust instrument, it is also an optical instrument and must be handled with care. Avoid exposing the instrument to high mechanical shock and vibrations. Avoid exposing the instrument to rapid changing temperatures. When not in use, store the instrument in a carrying case in a clean and dry environment. The lens does not need special maintenance. If dirty, carefully moisten the lens with ordinary window cleaning liquid and clean it with a soft lining cloth. If damaged, send the instrument to Delta or one of our authorized service dealers for repair. To make sure that the calibration of the retroreflectometer is correct, it is important that the surface of the calibration target is clean and undamaged. Keep the calibration target protected and be careful not to touch the calibration target, the reflective sites. If the surface is stained, scratched or broken, the calibration target must be replaced. A replacement calibration reference can be purchased from Delta or from one of our service dealers and changed by the user by unscrewing 2 screws and replace the damaged calibration reference. To ensure reliable measurements, it is recommended that the calibration target is periodically recalibrated or changed to a traceable standard. Delta recommends this period to be 2 years. Delta offers calibration traceable to international calibration institutes. General information on RetroSign GRX can be located on roadsensors.com under Products and RetroSign GRX. You will, among others, have access to the product feature leaflet and product specification in different languages, the user manual and the 2-page quick guide with the most important instrument functions listed, also in different languages. If you need additional information or technical support on GRX, you can either contact Delta or one of our appointed dealers. Delta can be contacted either through our website on the product support page or by sending an email to the following email address. Delta is an accredited calibration laboratory. Delta is accredited for 5-year periods by DANAC, the Danish accreditation body. An accreditation means that Delta's calibrations can be traced back to international reference laboratories like PTB in Germany and NIST in the US. This is your guarantee that Delta only delivers top quality calibration targets with our instruments. All Delta's instruments are properly tested and meet the European and US requirements when it comes to user safety and electromagnetic compatibility. Such documentation can be requested from Delta. We trust that this instruction video has been useful for you in getting to know the RetroSign GRX and its features. We recommend that you now take the instrument and start making field measurements to become comfortable using the GRX. If you should have any questions to the use of the instrument, please contact Delta or one of our appointed dealers for assistance.